Hey guys, so just like we would do in class if I was there, I want to go through a couple of these examples on this packet with you guys to get you started on it. Okay, first thing that I'm going to go over is number one. On number one, I'm going to start with um, this first equation. If you look, this first equation is already in slope-intercept form. So there's no work that you have to do to this equation before you graph it. You can graph it right away. So your first point is going to go at 7 on your y-axis. And from there, you're going to use your slope. Your slope is negative 11 over 8, right? Which means I'm going to count down 11, and then I'm going to move to the right 8. That's going to give me my negative slope. So going down makes it negative, and then going to the right gives me that negative slope. Those are the only points I can fit on this graph. So those are my points that I'm going to combine or draw my line through. Okay, my next equation, that second equation, again, is in slope-intercept form, right? I don't need to do any work. I can graph it right away. My first point here will go at negative 6 on my y-axis, and my slope is 1/4. So I'm going to go up 1 to the right 4. And you can see that's where my point of intersection is going to happen. Okay, I'm still going to put my points all the way across my graph still. Okay, but you guys can see that's where my point of intersection is. So the solution that we want to write down is the point where x is equal to 8 and y is equal to negative 4. But again, we're checking our answers. We're checking on all of these problems. We are checking our answers. So we're going to check by taking my first equation, I'm going to plug in, oops, no, that's not where I'm skipping a step. I'm plugging in negative 4 for my y value. That's going to be equal to negative 11 over 8 times my x value times 8 plus 7. Okay? No matter how you multiply it, whether you multiply negative 11 times 8 and then divide it by 8, or whether you recognize that the denominator and this number are going to cancel, when you multiply negative 11 eighths times 8, you'll get negative 11. So I want to make sure negative 11 plus 7, that will equal negative 4. So that point is a solution in my first equation. I kind of got some small space here, but I still need to check the second equation as well. So again, I'm plugging in negative 4 for y. I'm plugging in 8 for x. And then I'm checking. Again, no matter how you do it, if you multiply the 1 times 8 and then divide it by 4, or if you reduce these, 1/4 times 8 will give you 2. 2 minus 6 will give you negative 4. So the check works out. This is going to be your solution, that 0.8 negative 4. Okay? Again, no new information since the last time that I've been with you in person. You're graphing these just like we would graph them before. We're just checking to see where those lines intersect, and we're checking to make sure that intersection actually is correct. So if you look on numbers 1 through all the way to, let's see, number 7. 1 through 7, all of those equations are already in slope-intercept form. So there's no extra step that you need to take before you graph those completely. You just get to graph them and move on. Okay? The trickier problems are when we start at number 8 and get to number 14. So on number 8, if I look at my first equation is 3x minus 4y equals 8, right? That is not in slope-intercept form. So that I need to kind of adjust before I can graph it. Okay, if I wanted to get this in slope-intercept form, remember that's y equals mx plus b, I need to isolate the y by first getting rid of the 3x, right? I have to subtract it since it's positive there, so I get negative 4y equals negative 3x plus 8, right? Because the 8 was positive. Now, to isolate my y, I got to get rid of that negative 4 by dividing everything by negative 4. So again, keep your slope as a fraction. I will say a negative over a negative becomes positive, so I'm going to change that to 3/4 x. But then 8 divided by negative 4 is negative 2. So this is the equation that I'm going to put on this graph. My first point goes at negative 2. My slope is 3/4, so I'm going to count up 3, and I'm going to count to the right 4, but remember we could also go down 3 and to the left 4 for that same line as well. So there's my first equation. My second equation, this x plus 4y equals 8, if I wanted to solve this, again, if I want to isolate my y, I subtract the x. So I get 4y equals negative x plus 8. Remember, this negative x is really like negative 1. So when I go divide everything here by 4, I'm going to get y equals negative 1/4 x. And then 8 divided by 4 is positive 2. So I get negative 1/4 x plus 2. And that's what I'm going to graph. So my first point goes at positive 2. My slope is negative 1/4. So I'm going to go down 1, but then I'm going to go to the right 4. Okay. From there, I can also go up 1 to the left 4, but from there, that's what my line's going to be. And you guys can see your point of intersection already. Right? That point of intersection happens where x is 4 and y is 1. So that's what we're going to check, but we're checking it again into our original problems, into these equations. So for this first equation, 3x minus 4y equals 8, I'm going to plug in 4 for the x, 1 for the y, and I want to double check to see if this will all equal 8. So 3 times 4 is 12, 4 times 1 is 4, and 12 minus 4 does give me 8. So my point is a solution to this first equation. I still need to check the second one. Okay, just because it works in one does not mean it works in the other. I could have graphed the second one wrong. So that's one way you can check your errors. Okay, so first one, I'm going to plug in 4 for x, 1 for y. Double check to see if this equals 8. 4 times 1 is 4. 4 plus 4 does equal 8. So again, this will work for my second equation as well. Okay, so for question 8 to 14, so just 7 questions, you have to actually rearrange the equations into slope-intercept form first. Okay, and that's basically every problem we did on the note was problems like numbers 8 through 14, where we did have to rearrange the equations. Okay, I will say that on this packet, you should not get any of the special cases where you have no solution. You should have a solution for every single problem on this packet. But if you need extra help, if this is not necessarily the only question you need like some example on, if you wanted to go back to the notes from yesterday and look at those examples as well, that could help you. Okay, so 14 questions on the whole packet. I just did 2 of them with you, so really you only have 12 questions left. And the first 7 of them, again, you just get to graph them, find the intersection, and then check them. Okay, the last 7 is where it's a little bit trickier, where you have to rearrange it, like number 8. Okay, but my expectations for this, when you turn it in on Classroom, I need to see all of your work. So on question numbers 1 through 7, I need to see your equations graphed, and I need to see out this entire check. On questions 8 through 14, I need to see all of this work of you rewriting your equations and then graphing them, and then I also need to see this work on the check. Okay? So if you would like to, if the packet doesn't provide you enough room, you can do all that work on an extra piece of paper, but when you go to submit it, because this will be due at the beginning of class tomorrow, so you'll submit it to Google Classroom. When you go to submit it, you need to submit everything that has work. So you're submitting the packet, but you're also submitting all of the pages of scrap paper that you may have done your work on as well. Okay, just make sure that you're doing all that. So I see well, I don't see you, but we meet tomorrow. I believe it's last period. So last period tomorrow is when this is due, at the beginning of class. Okay?